Hello viewers, we are going to look at resolution of forces, and under resolution of forces we are going to consider parallelogram method. And so the question we have here is to determine graphically the magnitude of the resultant of the two forces shown in the diagram below using parallelogram law. So we are using parallelogram law to solve this problem. And so this is the diagram. If you look at the diagram, you understand that 300 Newton force is inclined at 40 degrees to the horizontal. And then we have that 200 Newton force is inclined at 20 degrees to the horizontal. Okay, for us to solve this question, we have to take a scale, and because a ruler is calibrated in cm and millimeters, so we have to take a scale to convert the force to centimeter first, and then when we are done with the plotting of the graph, we can convert it back to force. And so we take a scale. Take a scale, and we say that let 1 cm equal to 30 Newton. Let 1 cm equal to 30 Newton. And so for the 200 Newton force, let's have the cm equivalent of it by using this method. So we have 4. We say for the 200 Newton force, we have that 1 cm equal to 30 Newton. It means x will be equal to 200 Newton, since we are considering the 200 Newton force. So when we have here, we cross multiply. When we cross multiply this way, this by this, this by this, we are going to have x times 30 Newton equal to 1 cm times 200 Newton. So at this point, x times 30 Newton will be 30 Newton x, and 200, 1 cm times 200 Newton will be 200 Newton cm. So at this point, since we are looking for x, we can divide both sides by 30 Newton. So we say divide both sides by 30 Newton. So when we do that, we are going to have 30 Newton x divided by 30 Newton will be equal to 200 Newton cm divided by 30 Newton. So we can divide this will go. So this one, 6 into 20 will give us 6.66. We can approximate it to 6.67. This will go, this will go, this and this will go, so that we have that our x equal to 6.67 cm. So this means that for the 200 Newton force, the centimeter equivalent will be 6.67 cm based on a scale. And so we can now say for the 300 Newton force, we do the same thing. We use the same scale. 1 cm equal to 30 Newton, and so that our x will be equal to 300 Newton, since we are considering the 300 Newton force. And so we cross multiply. When we cross multiply, we are going to have x times 30 Newton equal to 300 Newton times 1 cm. And so x times 30 Newton will give us 30 Newton x equal to 300 Newton times 1 cm will give us 300 Newton cm. So again, at this point, we divide both sides by 30 Newton. So when we do that, we are going to have to divide both sides by divide both sides by 30 Newton. And so that is going to give us 30 Newton x divided by 30 Newton will be equal to 300 Newton cm divided by 30 Newton. This will go, this will give us 10, and this will go, so our x will be equal to 10 cm. So what this implies is that 300 Newton force will be represented using 10 cm in the rule. So having done this, we can now go further to plot our graph. So in order to plot the graph, we use our rule. Okay, so the first thing is for us to draw a horizontal line. We draw the first horizontal line. I want to use a pen so that it can be clear. Draw the first horizontal line. Okay, and then we draw our vertical line. So this is going to be our vertical line. Okay, we are done with that. So the next thing is for us to start with, the first force is 200 Newton force. Our first force is 200 Newton force. This is the 200 Newton force. 200 Newton force, and it is inclined at 20 degrees to the horizontal line. So we bring our protractor, we place it here, and ensure that this is how to place it. And then you take 20 degrees to, the horizontal. So we place it here. And then we say this is 10. This is 10 and this is 20. Okay. This is from 90. Okay, let me put it correctly. From 90 to 80 is 10. From 80 to 70 is 20 degrees. So we mark our point there, and then we draw a straight line to pass through that point that we've marked. So I draw a straight line to pass through it. Draw a straight line to pass through it. So straight line passes through the point. So we can now say that this is 20 degrees. So we say this is 20 degrees because our 200 Newton force is 20 degrees to the horizontal from what was given here, 20 degrees to the horizontal. So, but what is the length? From our own calculation using a scale, the length is 6.6 cm. So I'll pick my rule and measure 6.6 cm. Take 6.6 cm, pick my rule and measure 6.6 cm. So from my rule I'll have, this is 0, 1, 2, 3, 4, 5, 6.5.67. Okay, let me place it somewhere here. That is where it is. So I'll make an arrow here. So that is our 6 point. Okay, we can say 6.7. We approximate the 6.6 to 6.7. So 6.7 cm. Take it there at 6.7 cm. So this is our point. Now, I said it in my other video during the triangle method that when you're plotting a graph, when you're doing the graphical method of resolution of forces to determine the resultant, you do it from head to tail. So our next force is 300 Newton, but it is inclined at 40 degrees to the horizontal. The next force here is 300 Newton and is inclined at 40 degrees to the horizontal. So we have to take it. So, but we need to have a reference point. So we start our reference point here. We draw a small straight vertical line to pass through this point, a small vertical line. And then we can also draw the horizontal equivalent to be parallel to our line down here, so that we can take a reference. Okay, that's another one. Okay, I haven't done that. So since the 300 Newton force, look at it, the 300 Newton force is inclined at 40 degrees to the horizontal, we now pick a protractor, place it here, place it at that point we stopped, and then we count 40 to the horizontal. This is 10, 20, 30, 40. So this is 40. Note this is our horizontal line. I'll repeat it again. You place it this way on the horizontal line and you take 10, 20, 30, 40, 40. So we draw a straight line to pass through the point. Straight line to pass through the point we've taken. Okay, that is the point. Okay, so having done that, we've drawn the straight line. So we now say that from here, from that line down to the horizontal is 40 degrees. And so once we've done that, we now measure the length, and according to our calculation, the 300 Newton force is 10 cm. So we have, okay, we can write it here. This is 200 Newton force, while this one is the line representing 300 Newton force. So we measure the length is 10 cm, so we pick a row, and then from the starting point, remember in vectors it's head to tail, so head to tail. So we take, this is where our point 10 is, 1, 2, 3, 4, 5 down to 10. So we fix it there, and we have our arrow at where the point 10 is. Now in parallelogram law, we have to continue, because we have to take the first force. Now we have to take the first force again, which is the 200 Newton force. And so before we do that, we have to also have a reference point like we did. We are done with the 300 Newton force, so we have to take the 200 Newton force again from the head. So the first thing is to draw a horizontal line to be parallel to this other line. To be parallel to this other line, we draw it because that is where our reference point will be. And so we know that the 200 Newton force again is, okay, let's take this down. That is a straight line down. So we know that the 200 Newton force is inclined at 20 degrees to the horizontal, and this is the horizontal, and you know we have to draw it in such a way that it's going to be parallel to this other 200 Newton force. So we bring our row. This is our horizontal line, so it's going to be 20 degrees to the horizontal. So this is how to place your protractor. You place it this way, and then you measure 20 degrees. This is 90, 90 back, 80, 70. This is where 20 degrees to the horizontal is. So this is 70 down to 90 will give us 20 degrees to the horizontal. So that is how it is. And then you draw it down to pass through that point. Draw it down to pass through the point. And then we say that this is 20 degrees. 20 degrees to the horizontal, And this is the 200 Newton force, again, that we've drawn. And then we have to measure the distance in cm, which is 6.7. So we still place a ruler here from the point it started. And then we have 6.7. This is 1, 2, 3, 4, 5, 6. 6.5, 6.6. This is where 6.7 is. Yes, that is where 6.7 is. So that is a point for 6.7. And then we have our arrow down here, 6.7. Now, if you look at it, you understand that this line is parallel to this other one. This 200 Newton force up is parallel to the one down. So we have to complete it by drawing that of the 300 Newton force again. So before we do that, we also have to establish our reference line, and we know that it is inclined at 40 degrees for the 300 Newton force. It is inclined at 40 degrees to the horizontal, and so this is our horizontal line. So we now pick it, and we place our compass this way and this way, yeah, and then we count 40 degrees down. So this is 90, 80, 70, 60. From 90, this is 10, 20, 30, 40. So that takes us down to 50. So we draw a straight line to pass through it. And if your measurement is very correct, the straight line of 10 cm is supposed to terminate at this point. If your construction is very correct, your straight line of 10 cm should terminate at this point. Maybe there will be some fractions of cm added because of error, but it should terminate at this point. So you draw it down to this point, and you have your arrow here. So we've completed it, but we've not gotten the resultant yet. So we now have to find a resultant by drawing a straight line from this point down here. That is how to find the resultant. Draw a straight line from this point. Okay, oh, I didn't say that this one is 40 degrees. This is 40 degrees. 40 degrees to the horizontal. And this is 300 Newton force. And the length here is 10 cm. And this is 200 Newton force. The length here is 6.7 cm. So let's correct this to 6.7 cm approximately. Let's put it at 6.7 cm. Okay, so we have to draw a straight line from this point down here, and so that will be our resultant. Let me place it correctly. So I take my straight line down. So I now call this my resultant. This is my resultant. So I haven't drawn that line. I've called it my resultant. I have to measure the value of my resultant in cm so that I can now convert it to Newton. So my value, measuring it in cm from what I have here, my value of resultant in cm is equal to 16.5 cm. And so because our force is not in cm, so we have to convert it from cm to Newton. And so we have that our resultant equal to 16.5 cm. So we remember that our scale was, the scale we used was 1 cm equal to 30 Newton. And so if we are to convert this resultant in cm to Newton, we'll also have that x, we can call the resultant x, will be equal to, okay, not x, we can say that 16.5 cm will be equal to x. So if we cross multiply it that way, we are going to have that 1 cm, we are going to have 1 cm times x will be equal to 30 Newton times 16.5 cm. So 1 cm times x will give us x cm, which will be equal to 30 Newton times 16.5 will give us 495 Newton cm. 495 Newton cm. So if we cancel cm here, so our x will be equal to 495 Newton. So what this implies is that the resultant of these two forces given in the question is 495 Newton. Note that when you are plotting, always ensure that it is from head to tail, head to tail, head to tail, and then you close up the force polygon or whatever. You close up the vector with the resultant, and so you have the resultant, and the resultant given in cm, you have to convert it down to Newton by using the scale and doing what I have done here down to Newton. So basically that is how to go about solving determining the resultant of two vectors, or two forces rather, using the parallelogram method. And note that this line is parallel to this, they are the same line, while this is parallel to this. So that is it. Thank you so much for listening.